My name is Innocent Mapanda. I hope I find you well. I would like to thank all those who have subscribed to my channel. You motivate me to dish out more information. Right, so you can refer it and share my channel to your friends, to your relatives, so that they can also benefit from the lessons that I'll be dishing out during this lockdown. Right. Today we'd like to continue with our topic 3 figure bearing. So this is now part 3 of the topic. Like what I told you before, that 3 figure bearing, it also complements with other topics such as sine rule and cosine rule. So I have extracted a variety of questions from Cambridge that is going to help us to understand better. Right. We are going to start with the first question. The diagram shows 3 points PQR on horizontal ground. PQ is equal to 50 meters. PR is equal to 100 meters. And angle PQR is equal to 140 degrees. Calculate angle PRQ. Right. So since R is the middle letter, it means that the angle required here is located at point R. So let me put a capital letter R to denote the required angle. Right. So if you notice 140 degrees and 100 meters, we normally refer to it as complete set. Right. Being given an angle and the side opposite to each other, it means that you make use of sine rule. Right. Remember, if you want to calculate angles, you put signs on numerators and sides on denominators. So I'm going to put sine R. R is opposite to 50. So sine R is going to be divided by 50. Is equals to. Then on my right side, I'm going to put the complete set, which is sine 140 divided by 100, since 140 is opposite to 100. Right. So you earn some marks for doing that. Right. So our aim here is to make R the subject of the formula. This can be achieved by doing the process of cross multiplication. Right. This 50 is going to multiply sine 140. So it's sine R is equals to 50 sine 140 divided by 100. So to make R the subject of the formula, you need to get rid of this sine element. Right. So you place what you call arc sign on your right side. So R is equals to arc sign, open bracket, 50 sine 140 divided by 100. Make sure your calculator is in degree mode. Right. So to punch arc sign, you need to press this second function button first. So press second function, then you press the sign button, you get your arc sign. Put open bracket, punch 50 sine 140, divide it by 100, then you close your bracket. Right. You get 18,74. R is equals to 18,74. Right. So usually the examiners they require you to express your answer to 3 significant figures. So since 4 is less than 5, it means that 7 is going to remain the same. Therefore your final answer is 18,74. 7 degrees. This is how you make use of sine rule to calculate the required angle. I hope you are getting me in class. I want you to stay tuned as we move on to part B of the question. Right, welcome to part B of our question. Right, remember we got R is equals to 18,7 in the first part. Right, part B reads, the bearing of R from Q is 100 degrees. Find the bearing of P from R. Right, so if you are following in the part 2 of bearing, I told you that before you calculate P from R, you need to sketch 100 degrees first on your diagram. Right, so you need to understand that R from Q is good as Q to R, which is close to 100. Right, so 100 is going to be sketched on the diagram starting from the north pole of Q, moving in a clockwise direction. Right, so I'm going to touch the north pole of Q there, then move in a clockwise direction. So this angle is representing 100 degrees. Right, then 18,7. Bearing questions, they normally require you to round off your answer to the nearest degree. So 18,7, I'm going to write 18,7 is 19. I'm going to write 18,7 is 19 degrees. Right, so let us move on to the requirement of the question. Right, find the bearing of P from R. This is the requirement of the question. Find the bearing of P from R. Right, remember P from R is similar to R to P. Right, so I need to measure the required angle first so that I know my target. Right, R to P, it means that you need to measure the angle from the north pole of R, moving in a clockwise direction to touch the line connecting R and P. So this is the north pole of R. I'm going to move in a clockwise direction to touch this line which is connecting R and P. So this is the required bearing. Right, so for me to calculate the required bearing, I need to first of all identify this inner angle at R. Right, so remember in our previous chapter I taught you about allied angles. Having two parallel lines like this, and a transversal line. Right, if this is X and if this is Y, right, those angles are referred to as allied angles. They add up to 180 degrees. Right, so 100 and this required angle, they are above this transversal line which is QR. They are on the same side, hence they are allied angles or co-interior angles which add up to 180 degrees. Right, so to find R, I'm going to less 80 from 100. I'm going to less 100 from 80. So 180 minus 100, you get 80. So this angle is representing 80 degrees. Right, remember angles which complete a circle, they complete revolution, they add up to 360 degrees. So to find the required bearing, right, I'm going to deduct 19, both 19 and 80 from 360 to calculate this required bearing. Right, so our final answer is calculated as 360, right, minus 19, right, minus 80. 360 minus 19 minus 80. Right, so 360 minus 19 minus 80, it gives you 261 degrees. So 261 degrees is our final bearing, is our final answer. Since 1980 and this required angle, they complete a revolution, they add up to 360. So it's 360 minus 19 minus 80 to get the required bearing. I hope you are getting me, class. So I want you to stay tuned and wait for the next question which is coming. Welcome back to the next question. Right, it reads, the plane flies from Auckland to Gisborne on a bearing of 115 degrees. The plane then flies to Wellington. Angle AGW is equals to 63 degrees. Calculate the bearing of Wellington from Gisborne. So like what I told you, do not be terrified about the names of the cities. Right, we can represent Wellington by W and Gisborne by G. Right, so remember, W from Gisborne or W from G is similar to G to W. So we need to measure our angle from the north pole of G, moving in a clockwise direction to touch the line connecting G and W. So this is the north pole of G, right? I'm going to measure the angle. I'm going to identify the angle using a clockwise direction to touch the line connecting G and W. So this is our angle. This is the target, right? So how can I find this angle, right? The first thing to do to calculate this angle, we need to identify this inner angle at G. This inner angle at G. And remember the concept of allied angles. Those angles which are on the same side above the transversal line, they add up to 180 degrees. So 115 degrees and this inner angle at G are allied angles. So to find this angle, I'm going to less 115 degrees from 180. So 115 degrees from 180, you get 65 degrees. So this angle is representing 65 degrees, right? So the required bearing can be calculated using the concept of complete revolution, right? 63, 65, and this required angle, they complete a revolution, they add up to 360. So the bearing required can now be calculated by deducting both 63 and 65 from 360. So 360 minus 63 minus 65, you get 232. So your final answer is 232 degrees. Then you are through. I hope you are enjoying the lesson. Stay tuned as we move on to part B of the question. Welcome back to part B of the question. The distance from Wellington to Gisborne is 400 kilometers. So the 400 kilometers is right there on our diagram. The distance from Auckland to Wellington is 410, and this is the 410 kilometers being given. Calculate the bearing of Wellington from Auckland. This question was getting something like 4 marks, right? So the number of marks can even tell that you need to calculate using sine rule or using cosine rule, right? So looking at our diagram, we need to identify the required bearing first, right? W from Auckland is good as Auckland to to W. So you need to measure the angle from the North Pole of Auckland, moving in a clockwise direction to touch the line connecting Auckland and Wellington. Right, so this is the North Pole of Auckland, right? I'm going to measure the required angle. I'm going to identify the required angle using an arrow from the North Pole of A, moving in a clockwise direction to touch the line connecting A and W. Right, so the best way to calculate this angle, right, is to first of all identify this angle at A, right? If I calculate the inner angle at A inside the triangle, I will then add the angle on 115 to get the total bearing required. So let me put a capital letter A here, capital letter A, to identify the required angle. Right, so like what I told you in the first question, whenever you have what you call complete set, you make use of sine rule. 410 and 63 degrees is referred to as complete set. A side and an angle given opposite to each other, it means that you make use of sine rule. Right, so I want to calculate the angle at A. So I'm going to write sine A, right? So A is opposite to 400 kilometers, right? So sine A is going to be divided by 400. Then on my right side, I'm going to put the complete set, which is sine 63. 63 is opposite to 410. So I'm going to divide sine 63 by 410, right? Apply the skill of cross multiplication. 400 will then multiply sine 63. So on your left side, you'll be left out with the sine A is equals to 400 sine 63 divided by 410. To make A the subject of the formula, you need to get rid of this sign by introducing arc sign on your right side. So A is equals to arc sign, open bracket, 400 sine 63 divided by 410. Then you take your calculator, right? So arc sign, open bracket, 400 sine 63 divided by 410, close bracket. You get 60, comma 3. You get 60,37 degrees, right? So like what I told you before, that bearing questions, they normally require you to give your answer correct to the nearest degree. So let me take angle A as 60 degrees, which is not our final answer, right? But 60 is part of the final answer, right? So it means that this angle inside the triangle at A is representing 60 degrees, right? And the required bearing is starting from the North Pole of A up to the line connecting A and W, right? So to get the required answer, it means that I'm going to add 115 degrees plus 60 degrees. It gives you 175 degrees as your final answer. I hope you are getting it, class. Stay tuned as we move on to the next question. Welcome back to our next segment, right? The diagram shows some straight line distances between Auckland, Hamilton, Tauranga, and Rotorua, right? AT is cost 180 kilometers, AH is cost 115 kilometers, and HT is cost to 90 kilometers. Calculate angle HAT. So the angle required here, let me denote it by a capital letter A. This is the angle required, right? So a situation whereby you are given all the three sides of the triangle, and you are asked to calculate an angle, right? We make use of cosine rule, right? Let me give you the formula, right? Take for example, you have got a triangle like this, A, and this is B, and this is C, right? And this is side B, side C, and side A, right? Let's say we want to calculate angle at C. We want to calculate angle at C using cosine rule, right? The first thing to do, you write cos C. You write cos C on your left side, right? And all the three sides, A, B, and C, they are raised by power 2, right? Meaning to say that we'll be having A squared, B squared, and C squared. A squared, B squared, and C squared, they help you to formulate your numerator there, right? But the idea is, of the two sides that you have raised by power 2, they add each other, and only one side is subtracted. How do you know the side that is going to be subtracted, right? The side that is going to be subtracted is the side C squared, which is opposite to the angle required C, right? So on your numerator, you are going to write A squared plus B squared minus C squared. You less C squared. Why? Because cos of C, we want to calculate angle C. Angle C is opposite to side C. So the side which is opposite to C is the one that we subtract, raising it by power 2, right? Then on your denominator, there is a fixed 2. Then of the two sides that you have added, you have to take A, the product of A and B, without power 2. This is cosine rule formula, which is used to calculate angles, right? So we would like to apply this formula on our question, right? Remember, the angle required on our question is angle A, right? So I'm going to write cos A. I'm going to write cos A, right? First, right? Then the three sides that we've got 115, which is going to be raised by power 2. We've got 180, which is going to be raised by power 2. We also have 90, which is going to be raised by power 2. All the three sides, 115, 180, and 90, are raised by power 2 in order to prepare your numerator, right? But I told you that of those three sides that you have raised by power 2, one of them must be subtracted, and the other, they add each other, right? So which side are we going to subtract, right? Angle A is opposite to 90, so we are going to less 90 squared. Why? Because 90 is the side opposite to the required angle. It means that 115 squared and 180 squared are going to add each other. Then you have to less 90 squared, reason being 90 opposite to the required angle A, right? Then do not forget that we have got a fixed 2 there. And then of the sides that we have added, you take 115 and 180. This time around, we do not include the power 2. You get 2 marks for that, right? So we move on to the next stage, right? Maintain cos A on your left side. So I'm going to punch 115 squared plus 180 squared minus 90 squared. You get 37, 525 as your simplified numerator, right? We do the same on our denominator. 2 open bracket 115 close bracket, open bracket, 180, close bracket, you get 41. You get 41, 400. Right. So, to make A the subject of the formula, right, you need to get rid of this cos by introducing arc cos on your right side. So it's now arc cos of 37, 525 divided by 41,400. Right, then you take your calculator. Right, so arc cos, open bracket, 37, 525 divided by 41,400, close bracket, you get 24.98, right? So to three significant figures, it gives you 25.0 degrees. So 25.0 degrees is your final answer. 25.0 degrees is your final answer. I hope you are getting me, class. Stay tuned as we move on to the next part B. We move on to part B of the question. Right. Welcome back, class. Right. So I'm going to place 25. 25 degrees. It's A. Right. Remember, 25 is the answer that we got in the first part. Right. Part B. The bearing of H from A is 150 degrees. Find the bearing of T from A. So I need to sketch 150 degrees first. H from A is equals to A to H, which is equals to 150, right? So I'm going to measure 150 from the North Pole of A. This is the North Pole of A, moving in a clockwise direction to touch the line connecting H and T. So this we are going to measure it, right, to touch the line connecting H and T. And do not forget to indicate that this arc or this arrow is representing 150 degrees, right? So part B1, find the bearing of T from A. Remember, T from A is similar to A to T, right? So I want to calculate the bearing of A to T, right? What is the meaning of A to T? You measure your angle from the North Pole, of A. This is the North Pole of A, to touch the line connecting A and T. So this is the required angle, right? So remember, 150 degrees, the given angle, is covering from this part up to this part. And the required bearing is covering from this part up to this part. So the easiest way to calculate this required bearing, you need to deduct this 25 degrees from 150, right? So that you'll be left out with this part up to this part. So 150 minus 25. It means that your final answer is 125 degrees, right? Then part B2 reads, calculate the bearing of A from T, right? A from T is similar to T to A. So you identify the angle by measuring it from the North Pole of T, moving in a clockwise direction to touch the line connecting T and A. So sometimes examiners, they might not give you the North Pole of T. You have to draw the North Pole of T by yourself. So this is the North Pole of T, right? I'm going to measure from this North Pole, moving in a clockwise direction, right, to touch the line connecting H end, to touch the line connecting T and A, right? So for me to calculate this bearing, I need to identify this inner angle at T, right? Remember, we got 125 here, right? So this inner angle at T and 125, which is covering from this part up to this part, right, are allied angles which add up to 180, right? So 180 minus 125, it gives you 55 degrees, right? So for me to calculate this required bearing, I make use of the theorem of complete revolution. So 55 degrees and the required bearing, they add up to 360 as they complete a revolution. So it's 360 minus 55. 360 minus 55, you get 305. So 305 is your final answer for part B2. I hope you are getting in class. Stay tuned as we move on to the next segment. Welcome back to part C of the question. Right, it reads, calculate how far T is east of A. Right, when you see the word how far, you need to understand that the question is requiring you to calculate distance. Right, how far T is east of A. Right, so you need to understand the cardinal points. Right, remember our compass. We have got north here, this is south, this is west, and this is the eastern pole, right? How far T is east of A? You underline this statement, east of A. It shows that the owner of the east is point A. Therefore, you need to draw the eastern pole from the point A. East of A, the east is owned by A. Right, so remember, according to this compass, you can notice that east is located on your right side. So you have to draw a perfect horizontal line. You draw a perfect horizontal line on the right side of point A, who is the owner of the east. Right, so let me label it east. Right, so east of A is being represented by this horizontal line on the right side of A. Right, remember the question is requiring you to calculate how far T is east of A. So I need to draw another line from point T, which is vertical, so that the line is going to touch this east pole of A in such a way that it is perpendicular, or in such a way that it formulates a 90-degree angle with the east of A. This is the first thing to do whenever you encounter such a question, right? So the distance required is located on the eastern pole of A. So the distance required covers from point A up to this 90-degree angle. Let the distance be represented by X. Right, so you need to apply trig ratios in order to calculate the required side. Right, so the troubleshooter that we normally use is SOHCAHTOA. SOHCAHTOA. For example, this SOHCAHTOA sine theta is representing capital letter S, or is representing opposite divided by H, which is your hypotenuse. Right, same applies. Capital letter C is denoting cos theta. A is the adjacent divided by the hypotenuse. T stands for tan theta, where tan theta is equal to opposite over adjacent. So it helps you to memorize trig ratio formulas, right? So looking at x, you can notice that x is opposite to 55. This 55-degree angle, we have calculated it in the previous question. So x is representing the opposite. It is representing the opposite, right? And this 180 kilometers is opposite to this 90 degrees. Side which is opposite to the 90 degrees is known as the hypotenuse, right? So 180 is the hypotenuse, right? So having opposite and hypotenuse, it means that we can calculate the value of x using sine theta, since sine theta is the one which contains the opposite and the hypotenuse, right? So sine theta is equals to opposite over hypotenuse, and theta is represented by 55. So I'm going to write sine 55, which is the theta, is equals to opposite is x, which is the required distance. Hypotenuse is being represented by 180. Right, so to find x, we need to do the process of cross multiplication, where sine 55 can be treated as sine 55 over 1. 1 times x, you get x. 180 times sine 55, you get 180 sine 55. Make sure your calculator is in degree mode. So 180 sine 55, you get 180 times 5 sine 65, 180 sine 55, you get 147,4. 147,4. So to three significant figures, your final answer is 147 kilometers. Then you get your final marks. I hope you are enjoying class. Stay tuned as we move on to the last part of the question, which is part D. Welcome back to the part D of the question. Right. Angle THR is equals to 30 degrees. So we are given 30 at point H. And angle HRT is equals to 70, given 70 at R. Calculate the distance TR. Right. So looking at our triangle below, right, we can notice that 70 degrees and 90 degrees, they formulate the complete set that I mentioned before, right, which makes it possible for sine rule to be applied, right? So this time around, we want to calculate a side using sine rule. So I'm going to put sides on top and angles on denominators, right? So you write TR. TR is opposite to 30. So TR is divided by sine 30. Then 90 is divided by sine 70. Right. So to calculate T, we cross multiply so that sine 90 multiplies 90. Sine 30 multiplies 90. Right. So TR is equals to 90 sine 30 divided by sine 70. So 90 sine 30 divided by sine 70, it gives you 47,88, right? So to three significant figures, 1, 2, 3, your final answer becomes 47,9 kilometers. So this is how you calculate the distance TR. I hope you enjoyed the lesson. So I'll prepare another lesson bearing part 4, so that for those who are very slow, right, may catch up with us, right? And I'm going to leave you with an assignment to do as you enjoy your weekend. Right, do not hesitate. For those who have finished their assignments, you can post your work in my inbox so that I can mark it for you to check progress. Have a nice weekend and enjoy. Stay blessed.